Figure 3.4, the human eye. The human eye is a marvel of design and second in complexity only to the brain itself. The eyes started their development as outgrowths of the brain, so it's not surprising that both are highly complex structures. Let's take a tour around the eye, pointing out some of its features. Light enters the eye through the cornea, which is a clear, dome-shaped outer layer at the front of the eye. It's our biological windscreen, as it were, and contributes about 70% of the focusing of light on the retina. The cornea is only 550 microns thick, yet it is made up of 6 thin layers of tissue. Because it needs to be transparent, there are no blood vessels supplying the cornea, and oxygen needs to be obtained directly from the air. Light then passes through the pupil, which appears as a dark circular opening at the centre of the iris. The pupil is a hole, but appears black because light entering the eye is absorbed totally by the tissues and not reflected back. The diameter of the pupil ranges from 2 to 4 millimeters in bright light and expands to about 4 to 8 millimeters in the dark. Pupil size is controlled by 2 sets of muscles making up the iris. The sphincter muscles, which when they contract decrease pupil diameter, and dilator muscles, which increase pupil diameter. We are not able to control pupil size voluntarily, as we would respond to light changes far too slowly. Instead, it's under reflex control, taking only milliseconds to react to lighting conditions. Light then passes through the lens, where it is further bent to focus on the retina. The lens is not solid, as you'd find in other mechanical optical devices. It is more like a flexible bag of fluid containing proteins. It is highly transparent and receives no blood supply. The lens needs to be flexible and change shape to accommodate seeing objects at different distances. When you look at an object which is close by, the lens has a more rounded appearance. But when the object is further away, the lens becomes flattened. In A, you can see part of the front of the eye, and just to orientate you, this is the edge of the cornea, as it joins with the sclera, which is the hard outer part of the eyeball. This is part of the iris, and this is part of the lens. The outer rim of the lens is attached to ciliary muscles via suspensory ligaments called zonules. B shows what happens to the lens when focusing on close objects. Light enters the eye and travels through the pupil, formed by the iris, and then reaches the lens. When the object being viewed is close to the eye, the lens needs to get thicker to refract the light rays more so it lands on the retina. The lens gets thicker by the ciliary muscles contracting. When they contract, it releases tension on the zonules attached to the lens. Because tension is now released, the lens takes up its default rounder, thicker shape, increasing its focusing power to bring near objects into clearer view. C shows what happens when accommodating to distant objects. The ciliary muscles relax, which pulls the zonule suspensory ligaments tight. As the ligaments are attached to the lens, they pull on the lens, stretching it and making it flatter. A flatter lens has less focusing power, so you can see more distant objects. Thank goodness all this happens reflexly and rapidly without us having to think about it. There just isn't enough time to go into how the nervous system controls this reflex, but it is totally miraculous. When light passes through the lens, it focuses the image onto the retina at the back of the eye. What happens there is the subject of another video.